Hello children, in this lecture we will start new chapter hydrocarbons. So hydrocarbons are the compounds of carbon and hydrogen only. Okay students, so the compounds of carbon and hydrogen are known as hydrocarbons, and these are very useful compounds. There are a number of uses these compounds are having in our daily life. So the first heading is classification of hydrocarbons, and broadly we can divide these compounds in three types. Saturated hydrocarbons, these are the hydrocarbons in which all carbon-carbon bonds are single. So such type of hydrocarbons are known as saturated hydrocarbons. As for example, alkanes. Alkanes are the example of saturated hydrocarbons. The next is unsaturated hydrocarbons, and these are the hydrocarbons in which CC double bond or CC triple bond is present. So due to the presence of these bonds, such compounds which are having such type of bonding are known as unsaturated hydrocarbons. For example, alkene, which are carrying CC double bond, and alkynes, which are carrying CC triple bond, are the example of unsaturated hydrocarbons. And the last type is aromatic hydrocarbons. So these are the hydrocarbons which are having benzene ring. So students, benzene and its derivatives, which are made up of only carbon and hydrogen, are the example of aromatic hydrocarbons. So benzene itself is an aromatic hydrocarbon, and next example you can take as toluene, methyl derivative of benzene. This is also a aromatic hydrocarbon. Okay students, then saturated hydrocarbons are further divided in two types: open chain hydrocarbons and closed chain hydrocarbons. So open chain like aliphatic alkane, and closed chain saturated hydrocarbons like cyclic alkanes, cyclopropane, cyclobutanes, cyclopentanes, and etc. Unsaturated hydrocarbons, as I already told you, that alkenes and alkynes are the example of unsaturated aliphatic hydrocarbons, and same way we can take cyclic alkene or alkynes as an example of unsaturated cyclohydrocarbons. Then aromatic hydrocarbons like benzene, toluene, etc. Moving to next page, nomenclature of alkanes. So as you all know that we use suffix "ane", and in alkane functional group is CC single bond. Okay, and the general formula of alkane is CnH2n plus 2 for aliphatic alkane, and for cycloalkanes it is CnH2n. Okay students, so suffix "ane", general formula is CnH2n plus 2, and for cycloalkane it is CnH2n. Okay students, same way for alkene we use suffix "ene", and functional group is double bond, and general formula for aliphatic alkane is CnH2n. But for alkyne the suffix "ine" is used, functional group is CC triple bond, and general formula of aliphatic alkyne is CnH2n minus 2. Okay students, so examples are there of alkane, alkenes, and alkynes, of saturated and unsaturated hydrocarbons. The next heading is structure of alkane. So structure of alkane, in all the alkanes, central carbon atom is tetrahedral, is having tetrahedral structure. So central carbon atom with 4 valencies which are tetrahedrally placed from central carbon atom. So all the alkanes are tetrahedral structures. Then isomerism in alkanes. So alkanes are showing chain isomerism. Okay students, chain isomerism. So chain isomerism, for example, the molecular formula C4H10 is showing 2 chain isomers. First is normal butane and second is isobutane. Normal iso. So isobutane is having IUPAC name 2-methylpropane. Okay, so these two are having difference in their carbon chain. Normal iso. Next example we can take that of C5H12. So this molecular formula will show 3 chain isomers. First is normal pentane, second is isopentane, and last is neopentane. So in neopentane or in neo structure, particular carbon atom, one carbon atom is having 2 side chain attached with it. So such structures are known as neoforms. So normal with the straight chain of carbon, single chain. Iso is having side chain at second carbon, and neo is having 2 side chain at same carbon. Okay, so these are the chain isomers of alkane. The next is preparation of alkane. Preparation of alkane. Method of preparation of alkanes. So first is from unsaturated hydrocarbons. So unsaturated hydrocarbons are of 2 types, alkene and alkynes. So these unsaturated hydrocarbons under hydrogenation reaction are forming related alkane in the presence of metals like platinum or palladium. Okay students, so as example, ethene, when added with hydrogen in the presence of metal, ethane is formed, and when propine is added with hydrogen, propane is formed. So as you can see with the help of these examples, 1 mole or 1 molecule of hydrogen is added with alkenes, but with alkynes, 2 moles or 2 molecules of hydrogen are added with 1 molecule of alkyne. Okay, why? Because alkynes are having 2 pi bonds, whereas alkenes are having 1 pi bond. So for the saturation of 1 pi bond, 1 mole of the hydrogen will be required, but alkynes are having 2 pi bonds, that is why 2 moles of hydrogen will be required. Okay students, important fact, methane cannot be obtained by this method. Okay, why? Because all the alkenes and alkynes are having at least 2 carbon atoms. So methane cannot be prepared by this reaction. Okay students, the next preparation is Corey house synthesis. Corey house synthesis. So according to this reaction, we can prepare any type of alkane. Any type of alkane mean alkane of odd carbon containing or even carbon containing. Okay, So odd carbon containing alkanes are known as unsymmetrical, whereas even carbon containing alkanes are known as symmetrical alkanes. Okay, so according to given this statement, as we all know that Wood's reaction, with the help of Wood's reaction, only even carbon containing alkanes can be prepared. But with the help of Corey-House reaction, we can prepare any type of alkane. It can be of odd carbon containing or even carbon containing. Okay, students. So in this reaction, alkyl halide is first treated with lithium metal in dry ether, and due to this, alkyl lithium is obtained. Now this alkyl lithium is further reacts with cuprous iodide to yield lithium dialkyl copper, and this lithium dialkyl copper treated with a suitable alkyl halide, and after this particular alkane is formed. So as you can see here, that alkyl halide is treated with lithium in the presence of dry ether. Alkyl lithium is obtained, and this alkyl lithium is treated with cuprous iodide. So cuprous iodide, lithium dialkyl copper is obtained. Okay, and when this lithium dialkyl copper is reacted with alkyl halide, then we obtain alkane as main product and alkyl copper as byproduct with lithium halide. Okay, students. So as you can see, with the help of this reaction, that the last product alkane is having two alkyl groups. One alkyl group which was present in the initial alkyl halide, and the second alkyl group which is present in this last step in this alkyl halide. Okay, students. So what we are doing here, we are preparing alkane, and for the preparation of a particular alkane, first we reacted alkyl halide with lithium, and then same with same lithium alkyl lithium is reacted with cuprous iodide. Now in third step, different alkyl halide or same alkyl halide can be used. Okay, so if same alkyl halide we are using, then the alkyl halide of same alkyl group will form. But if we are using here different alkyl halide, then some different alkane will form which is having different alkyl groups. Okay, students. So for example, if we want to convert this ethyl bromide in propane, so as you can see here, in the case of propane, this propane is made up of two alkyl groups. One is methyl group and another is ethyl group, methyl ethyl, and starting compound is taken here as ethyl bromide. So at last step, we have to take ethyl bromide here, okay, to form this propane. So different alkyl halide we are using here. This is different and this is different. Okay, so if we want to prepare ethane, then we can use here methyl bromide. So if we are using methyl bromide here, then at last we will get ethane. Okay, so that's ethane. So ethane will be the alkane which is having two similar alkyl groups. Okay, so first methyl bromide with lithium is converted in the form of methyl lithium. and this methyl lithium with cuprous iodide is forming lithium dimethyl copper. This lithium dimethyl copper is reacted with ethyl bromide. Why ethyl bromide? Because we want to prepare propane. If we want to prepare butane, then we have to use here propyl bromide, and accordingly. Okay, so in the presence of dry ether, propane is formed. So this is Corey-House reaction. It's a very good reaction because with the help of this reaction we can prepare any type of alkane of odd carbon containing or even carbon containing alkane. Okay students, the next is from carboxylic acids. Okay, and from carboxylic acids we can use two reactions here. First is decarboxylation of carboxylic acid. So when sodium salt of the carboxylic acids are heated with soda lime, so alkane plus sodium carbonate is formed. So as you can see in this reaction that this portion is joined with this portion. So this whole will be converted in the form of sodium carbonate, and this H is joining to R, forming related alkane. Okay, so in this reaction CO2 is removed in the form of sodium carbonate. That is why the reaction is known as decarboxylation reaction. This sodium hydroxide is known as soda and CaO is lime. So when sodium salt of saturated fatty acids is heated with soda lime, then related alkane is formed. As for example, for the formation of methane, we will take as a starting compound sodium acetate. Okay, so this methyl group will convert in the form of methane with this hydrogen, and this part will be removed in the form of sodium carbonate. Okay students, and other examples are also given. The next reaction is Kolbe's electrolytic method. So in this reaction, sodium or potassium salt of acids are electrolyzed in an electrolytic cell, and due to the electrolysis we get alkane at anode. Okay, so according to this reaction, if we want to prepare ethane, then we take an sodium acetate as electrolyte in electrolytic cell, aqueous solution of sodium acetate. Water is showing aqueous condition of sodium acetate. So when sodium acetate is electrolyzed, we get ethane at anode plus CO2, sodium hydroxide and hydrogen as byproduct. Okay, so one drawback of this reaction is that we cannot prepare methane or odd carbon containing alkanes. Okay students, then next is Wood's reaction. Wood's reaction. So according to this reaction, when alkyl halides are reacted with sodium metal in the presence of dry ether, related alkane is obtained. So two molecules of alkyl halide are reacting with sodium metals in the presence of dry ether and alkane is formed. So as I have already told you that Wood's reaction is used for the preparation of symmetrical alkanes only. Okay, so if you want to prepare ethane, then you will take 2 molecules of methyl halide. Here methyl bromide is taken, and these are reacted with sodium in the presence of dry ether, then ethane is obtained. Okay students, so it is the drawback of Wood's reaction, or you can say limitation of Wood's reaction, that we cannot prepare unsymmetrical alkane with the help of this reaction. Okay students, why we cannot prepare? Because if we want to prepare unsymmetrical alkane, then in that case we have to take a mixture of alkyl halide. As for example, it is shown here. So if we are taking mixture of alkyl halide, then we will get mixture of related alkanes on the basis of different alkyl halides. So this mixture of alkane cannot be separated out easily. So that is why our this preparation will be not useful for us. So that is why we are using this Wood's reaction only for the preparation of symmetrical alkanes. Okay students, thank you.